Okay, so welcome back. We are looking at rates of change and tangent lines of a curve. And so I just kind of wanted to quickly go through what we had covered yesterday in class and pick up from where we had left off. So right now we're just trying to find the average rate of change of a function over an interval. We talked about what that is, and basically that was a slope between 2 points on a curve. And then we were just getting into what meant. We talked about what it meant to be a secant line and a tangent line, and how we're just getting into how to find the equation of a tangent line. So we were looking at finding the slope and equation of a tangent line at a given point. And that's where we had to end the class, and we didn't finish doing that. Okay, and so we'll get into the other things with some examples in a minute. So I'm just going to quickly bypass what we were talking about, except for this piece right in here. So our whole point here is that in our math careers before, we could only find slopes of lines. Now we want to deal with any function, any graph, and see if we can find the slope, the rate of change that is happening at one particular x value. And so the first thing that we looked at was just the average rate of change between 2 points on a function. And we looked at some graph, and we just found the slope between those 2 points. And basically that's just the average. If we had summed up, right, all the y values in between, but there's an infinite number, and divided by how many x values we put in here, that would give us the average value. But let's say we wanted to find what the average was, or what the slope was at one particular point. And so that's where we chose two values. One, the point that we're looking at, that we want to find the slope at, and one that's very close to the point that I'm trying to find the slope at. So let's say I wanted to find the slope here. I could choose a point not so far away. I could choose one closer, and I could find out what the slope was between those two lines. Graph the line in between. And that would kind of give me an idea of what's going on at this point. But the closer and closer I choose those points, the more accurate I'm going to be when I to the slope at that value. Okay. So we talked about the secant line. That was a line that joined 2 points that on a curve. That was, and the slope of the secant line, you would just find the slope of those 2 points. Okay. And so we kind of got into the value. Okay, let's choose that value close to some point that we want at x equals a. Let's say we're going to do a distance of h. And if we saw and we found the line between those 2 points and found the slope, we would get a better accurate thing if our distance between our point and what we choose h to be something very, very small is getting closer. And we called the slope at a particular point is going to be called the instantaneous rate of change. It has many, many names, that slope at the point, and we'll talk about it more and more as in the next few chapters. Okay, so we quickly reviewed how to find an equation of a line and how to do that. So we came up with an example, and I want to bring this up right now on Desmos, and I want us to graph that function and kind of look at what we've done so far. And so I'm going to go in, and I was talking about before I started recording that Desmos is a great program. I'm sure there's lots of other ones out there. This is one I know about that can help you a little bit to visual what's going on in calculus. So, and what we're doing, and to help us find some values for functions. Okay, so let me see if I can remember what it was. So it's square root of, let's say 4x. Gosh, guys, sorry. Plus 1 underneath the radical. Okay, so we have this picture here. And then what we wanted to do was we wanted to find the slope of the secant line between the point 0 and I believe it was 2. So let me just kind of go back to this. So find the average rate of change, the slope over the interval. Actually, it was at the point. Oh yeah, it was at 0, 2. So we went in, we found our points, right? We plugged in 0, we got the 0.01. We plugged in 2, we got the 0.23. We went in and found our slope, change of y over the change of x. And we found our slope was 1. And so then when we went to find the equation of the line, we got y equals x plus 1. So let me graph that on Desmos with the other equation. X plus 1. Oops, something's wrong here because that plus 1 should be underneath that radical. So let me just go back. Just a little different. And then we have y equals x plus 1. Okay, so you can see clearly, hopefully clearly, that you have your point here at 0, 1, which we found. And we have our point here when x was 2, y was 3. And then we moved on into the problem where we're like, okay, let's figure out what is this slope, or what is, well, first we want to find the slope exactly here at x equals 0. And so this is where we want to start plugging in values. Let's do it that way first to try to find the slope there. Okay. So I'm wondering if I can do this. I'm going to erase this instantaneous rate of change for now, and we can go back and talk about that in a minute. Sorry. Let's do this. Okay, so first equation, and then I'm just going to use f of x instead of our arcs of theta for now. Let's call f of x is equal to the square root. It was 4x plus 1. All of that was underneath the radical. And we found that well, we didn't find anything else. And now we want to find the instantaneous rate of change at x equals 0. Okay, so we have 1 point. If we plugged in 0, and this is where we got back the square root of 1, which was 1. So we had that 0.01. So we want to start finding slopes, and we want to find the slopes getting closer and closer to the x value of 0. Okay, so let's first start with 0.5. So 0.5, that's close to 1. We can get better. But if we go in and we plug in 0.5 into this equation, we want to know what we get back. And so this is where this Desmos program again is kind of helpful, because we're going to start plugging in numbers into a function, lots of ones and lots of decimals going out. And this is where it's going to be helpful, so we don't have to keep manually doing it to figure it out. So let's see. So I'm going to try to do 2 screens at once in a second. So I'm going to get out of the screen where it's graphing. I want to go back to where I come in, and I can go and look at different types of calculator. So I'm just going to go to the scientific calculator. I'm going to plug in our function that we're looking at, that we're going to keep on plugging in values for x. So f of x is equal to we have the square root. I could have used the symbol down here. 4x plus 1. So now I can plug in my x value to figure out what y is. And we saw, let me just do it. We saw that f of 0, right, was 1. Let's see what f of 0.5 is. So that's about 1.73. Okay, we want to find the slope though, right? So let me go back here just really quick. So this was 1.7325. So we can do that. We know that our slope between these 2 points, the change in y over the change in x, well, 1 minus 1.7325, or let's do it the other way. 1.7325 minus 1, that's 0.7325, all over the change in our x. So 0.5 minus 0. Or let this do the work for you. You're going in here, right? We were looking at our value, f of 0.5. And then we were subtracting off the other y value, which was f of 0. I'm going to close my parentheses because order of operations, I need those parentheses around both of those terms. Divide by, and you can see that I'm coming back down here. So remember the change in our y value. So 0.5 minus 0. So I really don't need to put that. I'm going to actually copy and paste this so that I don't have to do this all the time. Okay. So I push enter and I get back 1.46. Okay, so this is approximately 1.46. So remember, this was a cool problem because this was our y-intercept. We could know is just 1. So we actually know y is equal to equation of the secant line between those two as y is equal to 1.46 x plus 1. About, because I rounded. Okay, so let's get closer though. Let's say we wanted to find a point that was even closer to that 0.01. And so we would just want to choose another x value, an x value that was close to 0. So something closer to 0 than 0.5. How about 0.1? So I'm just going to go back up here and I want to find out what the y value is there. But really, I want to find out what the slope is. Because we know that equation, whatever it is going to be, because of the y-intercept is always going to be the same, 1, is going to be y equals the slope times x plus 1. Okay, so let's figure out what that slope is so we know what the equation of the line is. Oops, I didn't mean to do that. Okay, so our y value in this time is going to be 0.1, plugging that into our function f of x, minus our point that we're always going to keep the same, in this case, 0, 1, and then 0.1 minus 0. Oops, something happened.
I think there's 2 decimal places in
Oh,
the
thank
2
you.
periods.
Thank you, thank you, thank you. So this is equal to about 1.8. Okay. So we found the slope was 1.8. 1.73, 1.83, those are pretty close to each other, right? Those numbers, but we can even get better. Okay, so let me just write that down, 1.83. Oops. Did I do a mistake here? On 1.46, I thought I just said the other one was, yeah. Let me go back. Okay. No, no. So the other one, remember, I'm just gonna, again, copy and paste. Actually, let me copy and paste there. Was 1.46 was the slope. I'm sorry, I was looking at what the value at the point was. So the slopes 1.83 and 1.46. And unfortunately, I just want this here. No, forget it. Okay, so let's choose a number that's even closer to 0.1, or from 0.1 to 0. So how about 0.01? So my x value is 0.01. Oops.
There's two periods.
Yep. Thank you. So notice that my slope is 1.98, or almost 2. I'm just going to write down these. 0.98. One x was equal to 0.01. So let's just do one more. Maybe let's even go closer to 0 when we choose a point. I can add more zeros before that one. How about 5 zeros after that decimal and before our 1? So notice now I'm getting 1.999998. That's pretty close to what I had gotten up here before. And the more numbers that I put in, or more, closer I'm getting to 0, I get in, it looks like this number is approaching the value of 2, right? Technically, I don't have to choose the points on the left-hand side or the right-hand side of x equals 0. I could have been coming in on the left-hand side. So like if I'm trying to think of a number that's close to 0 on the left-hand side, I could put a negative, right? So negative 0.1 is close to 0. Negative 0.001 is close to 0. Negative 0.00001 is close to 0. So let's just look at that and make sure we're getting that same value, that it looks like it's getting closer and closer to 2 as we get closer and closer to that x value of 0. So if I go in here instead, let's put in a negative. I'm hoping that was like a negative there. And so notice that that's 2.00002. That's close to 2. So as I get in closer and closer to 0 on the left and the right, it looks like this is approaching the value of the slope of 2. So might be able to. Eeks. Oh, well, let's do a new. So if we go and we investigate and we look at these lines, all these lines with these different slopes, depending on which points we had chosen, we'll look at it, we can see that if we chose our slope to be 2, that is going to be a tangent line. It's just going to sit there on that graph perfectly. And so, and you'll see that the further away those points are from the point that we're trying to find the slope, the not as accurate as you're going to be. So we have y is equal to, let's just look at a couple of them. So I did this one, I did this one. I do 1.98 x plus 1. Y equals 2x plus 1. This is our tangent line. And the instantaneous rate of change is 2. So I'm just going to go back and I'm going to just graph a couple of these equations to show the difference between a secant and a tangent line graphically. And I probably should 1.83. So I'm just going to go back to my math tools, graphing calculator. Pulls me back up here. I want to graph again my equation that we were looking at, which was square root of 4x plus 1 underneath the radical. We looked at, if we were looking at the line between 0, 1 and 2, 3, we got, that was y equals x plus 1. We did that work. We look at y equals, we found when x was 0.05, actually I don't have that one, 0.1, we have y is equal to 1.83 x plus 1. So notice that, I don't know if you can see the difference, but notice that that green is looking like more of the slope in here at this point. Where this blue one, this line in here is a lot different. Doesn't look as much. But we could even get a better estimate if we had done a point closer. So y equals 1.98 x plus 1. I can turn some of this off now. Let's turn this one off. So they look very similar, but one's getting more accurate. I don't know if it will let me see it, but and that was a C for some reason. And the last one, we found that the instantaneous rate of change, the slope right at that value was 2. So y equals 2x plus 1. And so it's sitting there like that. So basically, how I kind of think about this visually and kind of visualizing how I would think that the tangent line would be, is think about that you're driving on the curve. So let me get rid of this. We're driving on this curve and it's nighttime, so we have to have on our headlights. And depending on where your car is, depends on how the headlights are going to angle. And so if I'm driving here, and I probably just going to need to copy and paste this. So the snippet tool.
I'm not sure if you're screen sharing.
Oh, thank you. I am not. Here, let me just see. So I'm just I just copied and paste that. So you're still not seeing. So I'm just to bring it over here. Let's get past that.
So just to be sure, how do we confirm that 2 is like the slope, that like answer to the instantaneous rate of change?
It has to do with the value, that slope. What does that slope get? What is that slope as we get closer and closer to that value? Choose points that are closer and closer to that value. Let me just, sorry, post this here. So basically, the more points that we choose that are closer and closer, we saw that this one wasn't very, I thought it was 1, 3. No, it was 2, 3. So the line between these two does not look like the slope right in here, right? But if I chose my value closer to this point that I'm trying to find what that slope is, I'm going to get better each time. So instead, if I chose it to be out here, and I looked at drawing the line between these 2 points, that's a lot accurate than what it was when I did it between those 2 points. And as I come in closer and closer, the distance between the X values get closer and closer, the more accurate I'm going to get. And you'll notice that as you plug in values for the points, and the X value is getting closer and closer to the value that you're looking at, in our case was 0, it's going to go towards one particular number. And so we saw that up here when we had looked at and it's way up there, we were looking at the slope, it tended to get closer and closer to that value of 2. And so because of that, and again, just to reiterate, it doesn't matter if I chose points on the left instead, it just has to get closer and closer. And we're getting infinitesimally close because we can say 0.0001, 0.00, and we can just add more zeros after that decimal to make it even closer. And so if it didn't go to one particular value, then it might not have a slope at that particular point. It might be undefined. And we'll talk about that later in the course. To me, how I kind of think about where that tangent line would be laying without having to do all the work is I would look at, again, like visualizing I'm driving. You're going to see my great driving or my great artistic skills. So if I'm driving, and I'm thinking, I'm visualizing how are my headlights going to be shining on this road? Well, they're going to be pointing upwards, right? And so basically, let me do it down here parallel. It would kind of look like this. But if I was driving over here, the way my headlights are aiming are a little different, right? It's going to be, and I'm trying to do it here. So it's going to be, they're going this way, kind of parallel. And so that slope, right, changes depending on, this is really steep, depending on where I am on my curve. So that's how I kind of visualize how that tangent line is going to be laying on the curve. I don't know if that helps. Okay, so let's pull in a couple of more examples from the book. Okay, so if you have the following equation. Let's say y is equal to x cubed minus 3x squared oops. Let's change it. How about x cubed minus 12x? Oh no, okay, sorry. I lost it. So I thought I was copying two different problems. I found it again. X cubed minus 3x squared plus 4. And we're going to look at it. It already tells you what your point is at the point 2, 0. And part A is asking us for the slope of the curve at the given point. And part B is asking us to find the equation of the tangent line at that point. So if they might have just said, let's find the slope at x equals 2, we would have to figure out what that point is, and we would go in and plug in 0. I'm sorry, at x equals 2, we would go back in and we would plug in 2 wherever you see an x, and you would get back 0. Okay. So we know that we want to find the slope of the tangent line. So we know that we also then need to find points or find values that are close to the x value that we're looking at. So we want to choose x values close to 2. So, okay, just start choosing values close to 2. And the closer that we get to 2, the faster it will kind of fall out. And so we can just choose some different x values. I'm wondering if we can notate this a little differently. Let's just do it. So we know that we had a point right at 2, 0. And now we're going to look at points close to 2. So let's look at, 2.1, 2.001. Wonder if we could just do this. This is our slope value over here. So another number that's close to 2. Well, 1.9 is close to 2, isn't it? And 1.99999 is close to 2. So let's figure out what the slope is between the point 2, 0 and these x values here. Oops. So I'm just going to go and I'll pull it over in a second. I'm going to plug in the equation. F of x is equal to x cubed minus 3x squared plus 4. Okay, so I plugged in the equation. So I'm now knowing that I'm doing it between my 2 points, 2, 0, and whatever else I choose. Remember, we can just think of this as the change of y over the change of x. So I can just plug this in. I know that my numerator is the change of y. So that's going to be f of, let's just call that f of 2, because that's our point we're using. Minus, we chose a point or x value close to 2. So we want to find that y value, you plug in 2.1. And we're going to divide that. So in my parentheses for the function and in my parentheses for that whole numerator, put the slash and that will get me down to division. My x value that I started with on my point was 2 and my y value, and then the next x value was 2.1, so minus 2.1. Oops. So notice that my value there, well, I'll bring it over in a minute, but that's 0.3. So we're going to see that as if we get closer and closer to 2, will this number get closer and closer to one particular number. So now let's try, I'm going to copy and paste so I don't have to type it all again. Now let's try 2.01 or 001. So all I had to do was change my x value and my y value. So notice here, this is 0.003. So let's continue. So maybe let's put in 5 zeros before that 1. So notice, remember scientific notation? This negative 6 exponent on the 10, that's telling me I'm moving that decimal place 6 places to the left. So I'm going to have 5 zeros in front of my 3. So to me, it looks like as I'm getting closer and closer to 2, doesn't this look like it's tending to get closer and closer to the y value or the value of 0? Let's just look at the other side of 2, which was like 1.9, right? Change that. It should also be tending to get closer and closer to 0 as we get closer and closer to 2. Okay, so negative 2.9. Okay, that's kind of close to 0. Well, let's see. Add some 9s though. I don't know how many I added. But notice that this is moving my decimal. So this is number, even though it's negative, that negative number is getting closer and closer to 0. So I can tell by this number, the slope tending to 0, that that's going to have to be the slope of that tangent line. And actually, the slope, when that slope of a tangent line is 0, that's going to help us a lot. We're going to be looking for those values. When is that slope of the tangent line 0 or the derivative 0? Those are actually really important points on the graph. Let's look at it. So I'm going to go up here. Okay, so here's our function. And notice that I have max and min in here. On this function, I have a maximum value when X is 0. I'm hitting a high point on my graph. I have a minimum value when X is 2. And that slope of the tangent line is horizontal. Remember, when our slope is 0, that's a horizontal line. So really, it's y equals. So we have this value. I didn't find that equation of the tangent line yet. I just did that. So let's go and do that because that's part B of this problem. I'm going to grab this. So we saw that the slope tends to 0. Okay, so find the equation of the tangent line. Remember, you need 2 things to find the equation of a line.
Equation and the point?
Right, so equation, not an equation and a point. A point and the slope.
I'm sorry.
Thanks for answering. So equation of the tangent line. Well, we had the point, it was given to us, right? We have our point was 2, 0. And we found that our slope was 0. So I tend to like to, there's multiple ways to find the equation of the line once you get the point and slope. You have your point slope formula, y minus y sub 1 equals m times the quantity x minus x sub 1. You can go in and plug it in there. I think that's harder because I like it things better in slope intercept form. It's just easier and faster to graph. And so if we go in here and we can work around that, we can plug in our slope. We know what our slope is, right? That was 0. We're plugging in our x value of our point. Our x value of the point was 2. We don't know what b is in our case. And our y value up here was 0. So I just need to know what my y-intercept is. And once I know my y-intercept and I have my slope, I know what that equation is. Well, notice that we get 0 equals 0 plus b. So we got b was equal to 0. So if I go back in, and not normally this will happen, but my m value is 0 and my b value is 0. So if I plug that back in, I have my equation of my tangent line. I got y is equal to my slope, which is 0, times x, which is 2. No, I don't want x. I just want x, sorry. Plus b, which we said was 0. Well, that's the same thing as the equation y equals 0, which is that horizontal line at 0. So it's just basically that x-axis. And that's where we saw that minimum, that what value was 0 when we looked at the graph. Okay. So I just looked at the time and perfect timing. So I'm not going to jump into another problem. So let's stop there. I will stop the video, or maybe just pause the video, and then if you guys want, I am here for you if you have any questions for student hours for as long as you need me. Let me stop the recording.